So today we're finishing up our 5.1c in our study of exponential functions with studying compound interest versus continuous interest. Okay, so you'll be successful when you can choose the correct interest formula, when you can identify the principal, the rate, the number of times compounded. Something really important to note is the type of interest rate that you're using. In our problem at the beginning, it was a monthly interest rate. Typically, they're annual interest rates. It's important to pay attention to that. And if in the problem it doesn't tell you specifically the type of interest rate, please assume it's an annual interest rate. Okay? Otherwise, it'll tell you specifically monthly or 360 to 365, whatever. Okay? And time. We also have to be able to identify time. And then you use objective 1 and 2 to answer the question. Here we go. Formulas that you need that are going to expedite this process. You've already been through the painful process of doing it step by step, month by month. Looks like this. A is equal to P, capital P, times the quantity of 1 plus a rate over the number of times compounded. This, again, remember, this represents the percentage of what you're going to pay back or you're going to make, 100% plus the extra rate, raised to the n times t power. Okay, so there's one formula. We use that when we're doing compound interest versus continuous compound interest. It's always compounding every second, all the time. Could you imagine trying to figure that out? Compounding every second, doing 1 second and doing the math, and then starting with a new number in 2 seconds. Oh, it would be awful. So this is where we're going to find E. E is representing continuous compounding, and that is raised to the RT. So I always memorize this as the word PERT. PERT, yeah. And back in the day when I was a kid, I'm going to date myself because you're not even going to know what I'm talking about. The first shampoo conditioner combination was called PERT. Yeah, you know, you can go get hair products now. It was the hair product for lazy people that didn't want to wash and then condition. You guys probably have a lot of those now, right? Lots of combos. Anyways, it was called PERT. And it was green. It was green. Came in a green bottle. Anyways, so that's how I remembered the formula for continuous interest. All right, let's break down what all these variables mean. A, let's go back up here real quick, and could you put that this is annual compound interest? We have to make adjustments to the formula if it's going to be some other type. Okay, and then so what's A stand for? This is the amount after time. It's your total, your final amount, the final amount of money you owe or the final amount of money you make. Okay, P, also known as P nod or P initial, is your principal. The grown-up word for your starting amount. I don't want you to say starting amount. I want you to call it the principal. Okay? By the way, when you see that sub-zero means starting. That's what that sub-zero is telling you. Where did you start? What was your base beginning? Okay? Before you did anything. All right. R is your rate, but it's in decimal form. Your rate in decimal form. And that means, remember, when you change a percent to a decimal, you have to bounce the decimal 2 times to the left. So if I say 1%, don't tell me that's 0.1. 1% is 0.1. 0, 1. Be careful. Okay? All right. N, sometimes known as K, depends on the textbook that you're looking at. Sometimes it's K. This is your number of times. That's why we call it N, because number. Number of times compounded. Yearly, because we are working on annual interest rate. T is time. And right now, we're working on time in years, annual interest rates, or continual interest rates. And E. E is representing our continuous compounding interest. Continuous compounding. And remember that we just round it to 2.72. Okay? But your calculator actually doesn't need to round it. So you'll use your calculator, and your calculator will give you a very precise answer. Okay, so let's move on, too many times, to the next box in our note page. Okay, so the question earlier was, why do we need E? Okay, well, I'll tell you, back in the 17th century when capitalism began and banking systems and people were borrowing money and they were starting companies and they were making money, if a bank was going to lend money, you had to pay you wanted to borrow, you had to pay extra, right? You had to pay an interest rate. And I'm sure it was some financial, of course, I'm just guessing, but I'm making an educated guess here, that it was some financial guru type that figured out E and figured out what was happening, maybe just out of curiosity. I'm not sure. But here's how we come up with E. When something is compounding continuously. Okay, so here we have this table where we have N, which represents the number of times something's being compounded in a year. Okay, and then what we have over here is our rate. What are we paying back? Remember what this one represents? 100% of what we borrowed. Plus, and look at our rate. In this case, our rate is 100% as well, right? And then divided by the number of times we compound in a year, and we're going to raise it to the number of times compounded in a year. What's our time here? I think it's 1, right? So this is just in 1 year. So you'll see that all of these things are basically a year in increments. So let's say I take $1, okay? And I invest it, and I'm supposed to get a 100% return if I compound it 1 time. What's 1 plus 1 over 1 raised to the first power? Try again. 1 plus 1 is 2. 2 raised to the first power is 2. I will double my money. Okay. Biannually. That, or sometimes, by the way, semi-annually would be another way that you might see that. That means it's going to compound twice. So it's going to take the interest rate, whatever it is. This interest rate is 100%, and it's going to divide it by 2. So that means it's going to do 50% the first compounding, 50% the second compounding, to make a total of 100%. And you get a little bit more, an extra quarter. So as you go along, as it compounds, 100% interest, you start making a little bit more. So what I want to know is, you're going to figure it out. How much will I get return if I compound monthly? So you guys sit and fill in those 4. Get your calculators out, fill them in. I'm going to press pause. And so you press pause, and then when you're done, press play and check your answers. Okay, so there we have filled out the table, and just comparing it to what E represents. we say that E represents 2.7182818 forever and ever. That's what E represents. And we can see that value. And honestly, once you get past the 10,000th place, this number is so tiny that unless you're working with really huge values, like in the billions, it's negligible. That's the same value that we came up with when we were compounding every second. So if we were to break it down to smaller values, less than every second, every half a second, every tenth of a second, we're still going to see the 4 decimal places, that 2 in the 10,000th place. So this is why we use E, because I'd rather plug E into my calculator than 31,536,000 in my N and raising it to the power of N. It would take forever. And I would make mistakes. So, thanks to the person who figured out E. Here we go. Now I'm going to ask you to make a prediction. We're going to do 3 problems, and I'm going to ask you to compare these 3 problems. There are 3 problems, and they're the same scenario as far as the most part. What I want to do is I'm going to read all 3 of them, and I'm asking you to predict which one will produce the highest income. Okay? And you're going to order them. Which one produces the highest, which one produces the lowest, and which one's going to produce the amount in between. So you'll rate them. Number 1 will be the one that you think will produce the highest income, and number 3 will be the one that produces the lowest income. Okay, so read along, and then think about what I'm saying and make your predictions. Number 1 says, the parents of a newborn child invest $8,000 in a plan that earns 9%. Now, that doesn't say annually or monthly, so we're going to assume annually. And it's compounded quarterly. If the money is left untouched, how much will the child have in the account in 55 years? Scenario 1. Scenario 2, would $20,000 invested at a little bit less percent, 7%, compounded 12 times monthly, have provided more income? And then the last scenario is this one. If the parents of the newborn child in example 1 had invested $8,000 at an annual rate, that time it tells you it's annual, yeah, 9%, compounded continuously, how much would the child have in the account in 55 years? So make your predictions in order, greatest income to least income, what these scenarios would produce. Okay, so here we go. Let's see if your predictions turned out true. So we're going to read through these problems and work through them, annotating as we go. So we'll mark the text and find the important information and identify objective 2, the principal, the rate, the time, the number of times compounded. Here we go. Parents of a newborn child invest $8,000. What's that represent? The P, the principal. They invest $8,000 in a plan that earns 9%. What's that? That's our rate. You got it. Compounded quarterly. Well, compounded, that's in, right? And how many times is it compounded in a year if it's compounded quarterly? 4 times. You got it. If the money is left untouched, how much will the child have in the account? You know that's your A. That's what you're looking for. What's the child going to have in 55 years? 55 years represents the time. Okay, so we have read through it and we have identified all of our information. So A is what we're looking for. Our P is 8,000. Our rate, we're going to change to a decimal at 0.9. Our N is 4. And our T is 55. So we're going to choose to use the annual compound interest, right? Because it's compounded quarterly. That's not continuous. That's just 4 times a year. So we're going to do A is equal to 8,000 times the quantity of 1. What's that 1 represent again? 100% of $8,000. I'm going to get it back. Plus my rate, which I have to divide 4 times over the year. So whatever 9 divided by 4 is, you're going to get a little bit of the rate at every 3 months. And you're going to raise that to the 4 times 55. Okay, so I'm going to plug that into my calculator. And by the magic of TV, boom, boom, or YouTube, because I'm making a video here, we are going to get a crazy huge amount. $1,069,103.27. I bet you didn't think that $8,000 could become that much by just sitting there, accruing interest. Some smart parents right there, right? Small investment, big payout. Okay, so let's go to the next one. You ready? We have to answer the question, would $20,000, which would be our new, principal, invested at 7%, which is our rate, compounded monthly, so our N is 12, have provided more income, so we're still looking for our A at time is 55. So we're doing A equals 20,000 times 1 plus 0.07 over 12 raised to the 12 times 55 power. That's a huge power, by the way. Exponential growth, I think, yeah? Way exponential growth. Okay, and it will produce, get this, 929,406.85. I bet you didn't think that the first one was going to outperform the second. I wonder how many of you got at least that right, that the first one is going to produce more than the second. Okay, good. All right. So now we have to answer the question because it said, would the $20,000 invested at 7% provide more income? Did it provide more? No. So we would have to say no. It provided, we'll do a little math here, $139,696. That's not $96. That's $96. And 42 cents less income. So, parents, do your research before you invest. Much better if you have $20,000 to put it in the 9%, compounded 4 times. Much better. Okay, so here we go on to the last problem. If the parents, let's start annotating or marking the text. If the parent of the newborn child in example 1 had invested $8,000, that's our principal, at an annual rate, look at that, it tells you it's an annual rate of 9%, that's your R, compounded continuously, so we have to use E. How much, that's what we're looking for, A, that's what we want to know, will the child have in the account in 55 years? There's your T. Okay, so we're going to use, instead of the annual, the compound interest, we're going to use continuous interest. So we're doing A is equal to our principal, 8,000 times E raised to the rate, 0.09 times 55. We're going to choose that formula this time. Let's see, you think it's going to produce more than the first scenario? It's compounding all the time. Yeah? I wonder how much more or less. So here we go plug that into the calculator and we get the amount, $129,399.71. Good luck finding a bank that will compound continuously. Maybe if you're borrowing money, but not if they're paying you money. Anyway, how was your predictions? Were you 1 out of 3 or 3 out of 3? 1 out of 3? Can't be 2 out of 3, because if you got 2 right, you got the third one right. Wouldn't work. Anyways, so there you go. So you're going to be doing problems where you have to identify all of the parts, pick the correct formula, and then use your calculator and remember to answer the question being posed. Your assignment picks up where we left off yesterday. You did to number 58 yesterday. So we're picking up on number 67, so you'll skip a couple. And then you're going to do 67 to 77 odd. So I've assigned you 6 problems. And then if you want, you can do 68 to 78 even for extra credit. And you can do 2 of them or all of them. It's up to you what you want to do.